This video describes what happens when a light refined fuel such as gas, diesel, or jet fuel are spilled in a creek. It also discusses what to do and how to clean it up. Essentially, two types of flows occur. The first is slow laminar flow, and the second is faster turbulent flow. Laminar flows are slow and even moving. There's very little distribution, both vertically and horizontally, within the water column, and in general, compared to turbulent flows, there is very little mixing. Because laminar flow is slower flowing, there's less mixing of the fuel with the water, and the fuel generally floats more on the surface. If it's on a slow-moving river, it tends to coat the outside corners of the banks rather than the bottom of the stream. Because light refined fuels are lighter than water, the general belief is that people expect them to float on the surface like they do in laminar flows all the time. That is not the case at all. In fact, in turbulent flows, the opposite is true. Turbulent flows are characterized by fast-flowing streams that are that way because of the steepness of the creek and the size of the substrate. They're mostly made up of large boulders and cobble. When the water passes over the cobble and goes over the drops, it mixes heavily with air, and the air is moved through a process called entrainment, and it is moved to the bottom of the stream and throughout the water column. The continual movement of water and air to the bottom is what rinses the eggs and allows the fish to breathe, and it keeps all the benthic or bottom organisms alive, and by providing them oxygen. When a major spill of light refined fuel occurs, it replaces the oxygen and the air that's mixed with the water, and the fuel itself becomes entrained and becomes trapped in the bottom underneath the rocks. It will stay there for a very, very long time unless it is disturbed. The definition of disturbing the bottom used in context means to either lift or agitate the rocks at the bottom to the point where the fuel can be released. This can be done by lifting the rocks or by shaking them up. In a small creek, this can be done by rakes and shovels, but in most cases in steep mountain streams, it is either too steep, too deep, or too dangerous for manual work, or the substrate is simply too large to be done manually and a machine must be used. When a catastrophic event happens, such as when a fuel truck goes in a river and releases all its fuel at once, it's overbearing for the stream and the entire stream bed becomes covered. Essentially, fuel becomes trapped under each and every rock in the entire wetted width of the stream. In the case of this river demonstrated, the distance was 2 kilometers. At that point, it went into a larger river and was more diluted. There's a special machine called a spider that has several different attachments for it, and it can be used for forestry, putting up ski lifts, microwave towers, but it's also specifically designed for in-stream work. It can work in depths up to 2.5 meters and is safe for large areas where it is absolutely unsafe for manual work to occur. Because of the substrate size, in the case as you can see here, clearly no manual work could be done whatsoever, and the fuel would stay at the bottom for a very, very long time, possibly up to a year or more. The balance of this video shows the spider machine working in an actual spill, and this machine is very, very versatile. Like the creek we're looking at here is probably about in the neighborhood of 35 to 40 feet wide at this exact point, and it can clean like about a 2-meter swath across there in roughly about 3 to 5 minutes. It's working back and forth right across the entire stream. The other thing that's very, very interesting about this is at one point downstream there was a steep bank and the machine had to come out of the river for fueling. And the bank was 5.5 feet high, and it was cobble and loose gravel. the machine approached the bank and basically lifted itself out without even touching the bank. And that's the kind of low impact that we're looking for actual use in the stream work. There is no better machine to do this job, and it is highly recommended that we use these machines as quickly as possible for all large spills of light fuel products in the future in this type of stream, which is steep and mountainous.